This video introduces user-defined classes, including the motivation for employing them, some syntax and terminology, and classes in user-defined modules. On first exposure, the concepts of object-oriented programming may seem a bit peculiar, but keep in mind that you've been working with objects, ArcPy objects, list objects, and so forth all through this course. Classes are just a way for you to define a blueprint for your own types of objects. As you study classes, think in terms of the types of objects you're dealing with in your own research. For example, if you are working with data pertaining to wild horse populations, you might create a horse class. The class you create can encapsulate the attributes that horses have and the actions they are capable of taking. A horse has a gender, color, and height, and it's capable of grazing, trotting, and so forth. Python is an object-oriented programming language. As a programmer, you never really understand that until you have the opportunity to create your own classes, which allows you to create objects. Though the utility of user-defined classes may not be obvious to you immediately, learning the basics for creating your own classes will doubtless deepen your understanding of the objects that you use all the time, the ones defined by others.
So that's what we're going to talk about, how to define your own classes and why you might want to do that. Object-oriented programming, we talk about that in terms of contrasting it with procedural programming, which was the paradigm before somebody came along with object-oriented programming. Procedural programming, you'd think about a set of variables, you make up your procedures or your functions, and they just all sit together in your code, but they're not very cohesive perhaps. With object-oriented programming, classes are a structure that you use to organize the code, and you think of things in terms of objects and how things are in the world relate to that object and what that object has. We'll talk about this in terms of a concrete example, make it a little more solid. Suppose you have a set of parcels, land parcels, and the parcels have IDs, they may have structures on them, they have zoning, assignment, a value associated with them, tax values, things like that. If you're using structures to describe the parcels in your code, you may think in terms of a list. So you have a set of IDs. Let's make a list of the parcel IDs. So we have our parcel list here. How would we add or remove a parcel with this structure? We could append, or we could pop. We can use our list methods that we know how to use. There's a remove method as well, which will get whichever one you specify. What about keeping track of the structures, the buildings and things that are on the parcels? I have an ID for each parcel, and if I want to associate structures that are on each parcel with them, you might want to use a dictionary. With a dictionary, you could then create a set of empty lists. Start out with every parcel having no structures on it. This is what this loop is doing. It's creating a set of empty lists in your dictionary. So then you'd have an empty list associated with each of the parcel IDs, and then if you wanted to add a structure to one of those parcels, you might define a function that would say append to the list for the specific one that you're talking about. If you had a situation where you needed to replace a structure, a building was taken down and a new building was put up, or there was something wrong in your database, you would need to define a function that would do a change for you within your data. So you could index in there and create and put a replacement in there for it. That handles man-made structures. What about other attributes like zoning and property values? So then you might need another dictionary or two for that. Then you might need another set of functions that'll handle adding or removing or changing the zoning regulations, tax values. So you would need something to handle every additional attribute that you have. Think about what would happen if, say, parcel number 1 was merged with parcel number 2, and you needed to get rid of one of the parcels. You'd have all of these dependent structures. You have to update your zoning dictionary, your parcel list, your value dictionary, your man-made structure dictionary, your tax dictionary, and so forth. It could become really cumbersome to keep track of all of that. And this is why somebody came up with the idea of thinking, rather than in terms of procedural programming, thinking in terms of objects. So if I think in terms of a parcel object, my parcel object has all of these attributes with it. And I can simply create a class structure that will allow me to create a new object. It'll have a set of attributes, and it can have a set of functions that handle doing things with that object. That's where the object-oriented programming comes in. We've used objects a lot. Remember the describe object we used for ArcPy? We could say import ArcPy, set up a path for a data set. We could call the ArcPy describe method, and it returned, remember what it returned? Yeah, a describe object. It gives you back a describe object which had property. You could now say DSC dot what, for example? Data type, yeah, because it's an object that has properties associated with it. And if you printed out DSC at this point, you'd get this funny comment, but it's saying it's a geoprocessing described data object, and that object is at this location. Recall the describe object has loads of different properties. Of course, that is dependent on the data type of it, whether it has each of the properties within the boxes here. But the general format was for accessing a property is object.property. It's the same thing when you create your own objects. Here's another example. It's a result object. ArcPy tools return result objects. Average nearest neighbor, it's returning 6 outputs. That's another example of an object that we've worked with. Of course, cursor object, the next and the reset, all row function. An object is defined as a collection of data and functions that operate on that data. So the data types that we've been working with all the time, integers, strings, list dictionaries, those are built-in Python objects. When we import ArcPy, we can use additional objects. Class, you can think of it as a blueprint for a collection of objects with identical characteristics, like a parcel, for example. There could be a collection of parcels, and they all have an ID, they all have a zoning, and they all have a property value, and so forth. The class keyword allows you to create user-defined objects. It provides encapsulation. It's a way to group logically related information. In ArcPy, you've seen this object.property format, and you've also seen the object.method format. That's if it's a function, we call it a method, what you're doing after the dot. Describe object, we have the data type. For the results object, we have an object count. For the field objects, what returns a list of field objects? ArcPy.list fields. Yeah. Field objects have name, properties, type, property. So I'm differentiating with property and method, but really when you look at the syntax, the big difference is the method you're using parentheses, and for the property you don't. Back to this term, object-oriented programming. When you think in terms of object-oriented programming, the program is, instead of being a set of procedures and variables, it's a collection of cooperating objects. Objects can represent real-world entities or abstract concepts. The objects could be parcels, they could be census tracts, they could be watersheds, and the objects have associated attributes and functions that we call methods when they're associated with objects. A different paradigm for the way that you look at program. This slide is meant to give a picture of thinking in terms of an object. In your code, you can have a human object which has attributes, like, for example, This dude has a brain, and he's got a heart and some nice shorts. The human class can have functions associated with it, or actions that the human can take, dancing or rock climbing. When you think of your project, well, you may have different kinds of objects. Anybody think of an object that they might have in their project?
Weather station.
Yeah, a weather station object. So what kind of properties might a weather station have? Yeah, it can have an X and Y location, maybe an elevation. It may have the time that the battery was set, or installation date, or sampling rate. For a weather station, what actions might it be able to take? So there may be like a sample method, like go ahead and sample at this time or something like that. It may have a reset, shut down and restart it. That's a good lead into trying to think about problems in terms of object-oriented programming. It's just sort of getting a little bit of a different shift to things, where you orient things around the objects in your code. This example I'd like you to do with a group, get together with a little group and read the description here, and then try to plan the object-oriented components that you would use to write a script that would use object-oriented programming to describe this scenario. It's based on a set of airlines and the flights that are going in and out. And you've got some hints down here where you would have airline, flight, and seat objects. Based on the description here, what properties these would have. I came up with 2 for airlines, 5 for flights, and so forth. And what functionality they would have, what methods would be associated with an airline, based on the description here. So I'm going to pause the recording. I'm going to start the recording again and see if I can get any volunteers to give me some properties. Airline properties? Yeah, name and flight number are probably good. They're numbered flights and they're named. And flights have flights have things like origins and destinations. So they have a departure time, an arrival time, and a set of seats. Seats have a row, a column. A lot of you are asking me, don't they have a seat number? Well, I guess your system could conclude a seat number based on the combination of row and column, right? Which is the way it's usually a combination of those two. Fare rate and a status. What's the status mean? Whether it's available or not. When you go online to book your seat now, there's a lot more innuendo. They're trying to get you to pay extra for that inch of extra leg room. There's all kinds of seat properties the airlines are trying to manipulate so they can squeeze that extra dollar out of you. So one thing that you may notice about the names for the methods that I used here, if you want to write a method, it's useful usually to try to name it something that describes what it does. Get the total flights, add a flight, remove a flight. A little bit of abbreviation here. It's acceptable when it's obvious. And also, I'm using a lower camel case. So syntax uses that class keyword. If you were going to actually implement these things, you would create a airline class or a flight class or a seat class, one for each of these objects that you've described here. For the syntax, it's very much like other things that you're already familiar with. It uses this block definition of a set of things by putting a colon at the end of the first statement and indenting any of the statements that are grouped with that. In this case, we're going back to that little dude. So we're going to implement a human class, then we use a class keyword, name it. Convention for naming classes is to use an uppercase letter to start with. We can define some procedures inside of there. So when you define a class, you always want to create a function that's named init inside of there, so the init method. And this has 2 underscores on each side. So 2 on the left and 2 on the right. If you've got that syntax wrong, it's not going to work correctly for you. And you're going to see self a lot. I haven't actually explained that yet. That's why you couldn't understand that. I'll have a slide on that coming up. So that is what it looks like. We'll get into the weeds in a second. So this is the blueprint for the object. You're creating a class. So we have to create that class to define an object. So we're creating a template for what a human object is going to look like. But it's not the object itself. When you want to use a human object, you have to instantiate the class, which is just a fancy way of saying you call, it looks like a function call. You call the class, and that returns an object for you. And you use an assignment statement to get that object. So let's look at this human class, the instantiation process. So think of this as a blob. We've created a class, a human class. When we do this statement right here, human parentheses, and set that equal to Ken, we are instantiating an instance of a human object. We're going to return a new human object to the variable Ken. When we call this, it goes and it looks at that, the init function inside of there. It does anything that we've defined inside of the initialization function. In this case, we have two properties associated with the human class, a shorts property and a heart rate property. This is because of that little picture we had with the boxer shorts. So they're ugly yellow to start with. We're defining that. And we're defining his heart rate as very low, 60. It's very calm to start with. Also in this class definition, we have another method, which is the fall in love method. When we do Ken equals human, empty parentheses, we're instantiating an instance of a human object. In other words, we call this guy, it returns a human object, and we're setting Ken to that. So if we print out Ken, it's going to look like this weird statement. It's a human instance at this place in memory, and it's defined under the main function. So that was the statement that printed Ken. If we then go and say print Ken.shorts, it's going to print ugly yellow because we've set his shorts to ugly yellow. If we then say Ken.fallinlove, it's going to look for this method inside of that class, and that method sets the heart rate to twice as fast and prints a statement. So it'll set him off to falling in love, and it'll print I love GIS. So let's get into the bits that we had in this example. We got all kinds of new looking things. We've got the init, we've got the self. What's that self thing doing? We have some class properties. We have a class method. We're instantiating the class, and we have an object instance. So I'm going to work my way through these terms. First of all, the object instance. In order to use the class, you've got to create an object instance, and it looks just like calling a function. You put the name, and then you put parentheses. Whether or not they have something in them, that's another story for another slide. And then we assign it. We use an assignment statement to assign that object to somebody. This code itself in the white box is defining the class, and this is creating an instance, an object instance, and making use of it. So you'll notice that up here it says self.shorts, and down here it says Ken.shorts. We'll come back to that in a minute. We've been using this term method. A method is just a function or a procedure that's just defined inside of a class. So init is a method, fall in love is a method, change shorts is a method. It's just another name for a function. The notation remains the same. We're still saying when we get that Ken, that human object, we still say object.method to call the method. And we say Ken.changeShorts. That passes in the color blue. It changes his heart rate for some reason to the color blue and prints I love GIS. Maybe not what I intended to do. If you can say he has shorts, in the picture he has a brain, he has ribs, he has a heart. Those are properties that you could add to that class if you wanted to include those. But in this example, he just has the properties of shorts and heart rate. So in the init method, they're being set, initialized. And often that's what you'll want to do with properties. You'll want to initialize them to something, whatever the default value is, inside of the init method. So we initialize shorts to ugly yellow, we initialize heart rate to 60. If we call the fall in love method or the change shorts method, it changes the heart rate from 60 to 120. The way we access these properties, and one of the great things about classes is that you can access them within the different methods without passing them in. Notice fall in love is talking about the heart rate, but I didn't pass that in from anybody. I can simply reference it because that information about the heart rate is stored with that object. I'm a human, I have a heart rate of 60. Somebody does the fall in love method on me. I know my current heart rate is 60, I can just double my heart rate to 120. And that's where that self term comes in. For this example, let's have a really simple class, a point class. We can set x and y values of the point class. The init method, in this case, what's the difference between this one and the ones that we were just looking at? In the init method, in this case, it says self and x and y. It has a list of parameters in addition to self. And if you look at what we do when we invoke it, just below the green line there, we're calling point. Do you see how many parameters we're passing in there? 2. But how many parameters are listed up in the init? 3. So that's the way you do it. The self, it's automatically associated with the method. It's like you got to put it there, but then you got to ignore it. When you create any method within the class, you want to put self as the first parameter that you pass in. And then when you talk about any of the attributes that the class has, if you're referring to them inside of the class, inside the init method, inside of any of the other methods, you say self.x, self.y. When you're referring to them outside, once you've created an instance of that object, you say instance name.x, instance name.y. So that's what we're doing down there. We created point 1, and then we print that object, which it'll just give us a ugly thing like this, point instance. But then if we say print point1.x, it prints that value. And point1.y, it prints that value, 200. Any guesses how, if you wanted to change the x value, move that x value to 300, how you might do that? Well, since it's a property, you don't even need to define another method. You can just refer to that property and change it. So how do I refer to that property? The object name .x. So I can say point1.x equals 300. Boom, it's changed. And then the class itself is going to keep that information with it. Self has got to be there. It's looking for that. It's a convention that it's called self. You could call it foobar, but you're going to have weirdo Python code which nobody else is going to understand. You'd have to then refer to it as foobar everywhere. Just use self. So the init is used to give initial values to things. Use self to name the first argument in any function that you create within the class. And then use one less argument than what you have in your list. In calling parcel, we say 145,000 in residential. We're passing in, so we can initialize the value and the zoning. And then you use self.property to refer to that property inside of the class. And then object name.property outside of the class. So when I say myparcel.value or myparcel.zoning, I'm referring to whatever value, me as the my parcel object, whatever I have associated with me. So in this case, it prints out a value of 145,000. When I print it down here, I call my calculate tax method. Notice how I refer to the zoning up here, inside of there, without passing it in, without defining it inside of this function. I'm using it because it's a property, it's an attribute of this class, because I've defined it up in here in the init. That way, I don't have to pass it in. I don't have to write calculate tax so that the person that's calling it needs to know the zoning. It just has it associated with it. And then it sets the tax value based on that. And it also uses self.value. Why doesn't it use self.rate? Yeah, that's locally defined right there. It's not a parcel attribute. That's practice. There's a parcel class that has a lot of blanks in it, but the important part of the instructions here, see how they're numbered? You need to do them in order. Get number 1 working, try to run it. Get number 2 working, try to run it. Do them in order of the numbering, not in order that they appear in here. You go where you see the number signs.
Pause the video to try it now. Part 1 on line 30 creates a second instance of a parcel object with a value of 1,000 and a zoning of industrial and acreage of 0.2. Part 2 prints the value of the newly created parcel object, and Part 3 calculates the tax, calling that method. So those are lines 31 and 32. For Part 4, an additional attribute named acreage was initialized. In the init function, line 2, in the signature, an additional attribute was passed in, and on line 6, the acreage is initialized. This enabled us to reference the acreage attribute in the new method that we create on line 18, the calculate SF, which multiplies self.acreage by 43,000 and returns this value. Then on line 35 near the bottom, we create another parcel object and call that new method to test it out. Finally, printing the return value on that last line. One common mistake is to write calculate SF to take a acreage argument instead of using the self.acreage attribute, which is available because we've initialized it in the init. Part 8 added the conditional statement on line 22 and indented all of the code that is not inside the class definition so that it's inside of the conditional block. This makes it so that this script can be imported as a user-defined module, and the indented code on lines 24 through 27 will not be run. We'll return to this and Part 9 in a moment. Taking a moment to reflect on some of the things we learned from that exercise, a class is simply a user-defined compound type. It's more complex than built-in primitives like integers, strings, or lists. You can define class attributes and methods. To create an object from a class, assign it to a variable. Access object attributes and methods using dot notation. Update attribute values using an assignment statement. If the value of parcel object P suddenly becomes 2.5 million, you could say p.value equals 2,500,000. What would it look like to change the zoning of a parcel object named my parcel to residential? In practice, classes often reside in user-defined modules so that they can be used by multiple scripts. This means you should place non-class code inside an if name equals main conditional block just like we talked about in user-defined modules. So that would be where you're testing your code that is not meant to be run when the module that the class resides in is imported. Then, when you want to use the class from a separate script, you import it like any other user-defined module and use module name .class to create an object. Once you have that object, you use it just like before. Notice that there's no need to say parcelClass.p. It's just p. p.calculateTax, p.zoning, and so forth. In our in-class exercise, Urban Planner and Parcel Class reside in the same directory. This means we can simply import Parcel Class without modifying the system path. Line 2 of urbanplanner.py shows Parcel Class being imported. Then on line 3, a parcel object is created. Notice that we say p equals parcelClass.parcel instead of simply saying p equals parcel. That's because we're calling it from another module. Then on line 4, we commence using p just like we would if we had created it inside of the parcelClass.py module. So we've made our parcel class more reusable by placing it inside of a user-defined module that can be imported without running all of the test code that's in there from lines 24 through 27. Summing up, a class is created using the class keyword and then the name of the class, usually capitalized. And then inside of the class definition, you indent, just like any other block that has a colon to start it, and define functions that we refer to as methods. There's always an init method, and every method takes an argument called self. But that is passed in implicitly, so when we call those methods, we don't pass in an argument to match up with self. That's automatically defined when it gets inside of the function. You can instantiate a class to create an instance of an object. The class is like a blueprint, and then the object will have all of the attributes that are defined inside of the class. When you create an object, that object's attributes persist and are defined for that object. When you refer to its attributes inside of the class, you say self.zoning, self.acreage. When you refer to the attributes outside of the class, you refer to them by the name of the object, dot. So we had p.zoning, p.value, for example. This is one of the great things about classes, that it organizes all of that information together with the object. So if something needs to change, you change it with the object and it's stored there with that object. And we cast our minds back to our example at the beginning with all the dictionaries. If you needed to get rid of one of the parcels or replace one of the parcels, you would just have to deal with the object that is storing that information. In the last section, we saw how to store a class inside a user-defined module and reference that from another script. This makes our code that has classes very reusable. So it's often a good idea to embed your class in a user-defined module and then import it. In the upcoming lessons on mapping module, you'll use a lot of objects. Those will not be user-defined, but maybe you'll have insights about how those work because you've seen under the hood how classes are created. And in working with HTML, we will be talking about a script called Beautiful Soup, which contains a class called Beautiful Soup. And we will be using that with the module.class notation. Now that you've seen some examples, perhaps you can think about your project in terms of what objects exist in that world. What objects could it be useful to define, and what properties and methods do they have?